Welcome, welcome, welcome everyone to Pydata Global Day number 2. Without further ado, it is my esteemed pleasure to welcome our first speaker to kick off day number 2, and it is Adam. So if you all will give us a warm virtual welcome to Adam.
Excellent. Thanks a lot. Thanks for having me. Good morning, everybody. It's a pleasure for me to kick off the day today. So my name is Adam Cowley. I'm the manager of developer education at Neo4j. And my day job is to teach developers and data scientists everything they need to know to be successful with Neo4j. And we do this through Graph Academy, which is our online training platform. If you've not heard of Neo4j before, instead of storing data in thinking of data in terms of rows and columns, we store data as nodes connected by relationships. So nodes typically represent things. You can think of that as like a row in a table. We identify them with one or more labels. So for example, a movie can also be an animated movie. It gives us a way to group nodes by type. And we can describe the data we have in our database using properties, which are key value pairs. Any two nodes can be connected by a relationship, which has a type and a direction. And this allows us to explore data, to find hidden patterns in data, and also to do complex query joins. But that's not what I'm here to talk about today. When I started preparing the talk on this topic, I assumed that this would be something about winning football games, but in reality, what I'm here to talk about today is really more a story of making sense of data, translating statistics into natural language, and really providing an interface that allows anybody to access data. So if you think of the problem of football in a divide between analysts and managers, and I think this is typical of any industry really. So we have an analyst here who in this case, walks, talks, and acts like a tactics piece from The Athletic, talking in acronyms and um, terms, statistical models, to a manager or an executive who has deep knowledge of their business, but doesn't necessarily have the ability to analyze the data. I think even though we have an example here of two people saying exactly the same thing, they're using different terms, and they may as well be talking different languages. And this, really the what the two are talking about is really lost in translation. And this is a topic that came up recently in an article on the BBC Sport website, where Tony Pulis, a very experienced manager, um, was talking about his recruitment process and how all of the data that he used, like his database, was in his own head, and none of his sign-ins were data driven. But almost immediately, he went on to talk about the Rothmans football yearbook, which is nostalgic for me because I used to get one of these every Christmas, and I used to enjoy opening it up and looking for Swindon Town, my local club, inside there. But something struck me with this article, which it was kind of summed up nicely in the comments. It's a book full of data, and I think like for the most part, we're looking at the same data and the same measures of success. But now the data is just stored and accessed in different ways. It's a different skill set and different ways of actually working with that information. And my hometown club is Swindon Town. And the manager Ian Holloway had his say recently in an interview with the local paper, where he was talking about the way that the language is changed, talking about terms like provoking the press, 2 6s, 2 8s, and that kind of thing. And this is an experienced manager with over 1,000 games under his belt, who's literally taken Swindon Town from the bottom of the professional leagues, the bottom of the fourth tier of English football, to the top within 9 months, and clearly knows how to win football games. And the data that's provided by the data providers is designed exactly for him. And he kind of ended this interview with some exasperated advice, just ask ChatGPT. And to be fair, like this is a topic that I probably spent too much time talking about. You know, I my role at Neo4j is to use generative AI and knowledge graphs to teach developers and data scientists about knowledge graphs. And I've always been interested in data and always been interested in looking at opportunities to apply graph thinking to football analytics. So I couldn't help but jump in on this subject. So there are challenges there as well, but I think there are also massive opportunities. The main problem we have with LLMs or large language models, so like the GPT series that power ChatGPT, is that they're powerful, they're highly useful, but essentially they're just next word predictors. They use patterns identified in large corpuses of text to predict the next word in a sequence based on the input. And so when you prompt an LLM or you provide it with instructions, all you're doing really is narrowing down that search space and the possibilities of things that could be generated. And I guess the second problem is that the LLM itself has no knowledge of what it's generated. It's just generating word after word. And this, coupled with a lack of access to real-time data, causes the models to hallucinate or present false and misleading information as a fact. Now, the models that are most prone to this, the companies call this a feature, and it absolutely is if you're trying to generate novel data or kind of novel insights. But in industries where accuracy is paramount, I think this is a real problem. So to solve this problem, a technique called retrieval augmented generation, or RAG, surfaced around about the end of 2023. And it's an all-encompassing term for improving the responses generated by an LLM by augmenting the responses by retrieving information from additional data sources. And in this case, you don't use an LLM for its knowledge. You use it instead for its language generation skills. And as these models are increasingly being fine-tuned for reasoning or breaking down large tasks into smaller logical steps, the term context engineering is emerged. So with RAG, there's a rigid retrieve then generate pipeline that struggles with complex problems where multiple retrieval steps are needed or different type of information um, needs to be accessed. So the way that we kind of solve this is combining the fine-tuned outputs of inputs and outputs of LLMs, both the tool calling and also structured outputs, to create these agentic flows. So the React pattern has probably emerged as the most common. It's probably the easiest one to get started with, where it takes a different approach. So the LLM is responsible for reasoning about, sorry, the LLM has access to tools via a piece of software which we call an agent. And then it's the role of the LLM that drives the application or the agent to reason about the problem at hand, and then act by calling those tools and observing the results. And this pattern gets repeated until there's enough context to respond. So instead of having one retrieval step up front and just stuffing everything, all the context um, into the prompt that you send to the LLM, the context is built up incrementally through a loop. So if we can provide an LLM with access to up-to-date football event data, we can assume it could work pretty well as a football analyst. So there's two types of data that we can provide an LLM around football. So firstly, the event data. So key actions that have happened in a match, the actual on-ball actions performed by players. And then on the other side, we have tracking data, which is the precise GPS-powered location data, which is captured multiple times a second. Now, while the tracking data is useful in many contexts, like for example, like identifying physical load for sports science. It seems that it's rarely available for opposition analysis, and probably will present more noise than signal. The event data itself provides a more aggregated view, and highlights key actions in that are performed in the game, which is both useful for opposition analysis and also player recruitment. Um, the the volume of data makes storing this in a database necessary. So a single match has upwards of 3,000 events, which roughly equates to about 2.8 million events per season. And because this event data is a sequence of interconnected actions, a graph database is a good place to store this. Um, and one of the things I've noticed is that even the most advanced metrics that we have, we speak about today, are aggregations of single actions, which to me seems like a symptom of the limitation of the underlying storage. Um, Whereas within a graph database, we can store the events in this next loop, and we can see that from an event that happens, we can see the context of what happened around it, not only um, what the player has done, but was the ball with the goalkeeper within the last 5 passes before the shot. And you can read more about this by following the link to the blog post. I think it was written in 2021. So this has been something on my mind for a long time. But if we're talking about 2025 is the year of the agent, and this is a quote that's been claimed by many. I think it was originated. I think somebody from NVIDIA said it. Um, Now we have this React pattern. We can provide access to data with tools. Um, Now, Model Context Protocol, or MCP, is a standard that was first introduced by Anthropic in November of 2024. And what this does is just defines a standard, universal way to define tools, resources, and other artifacts that can be used by agents, or in their terminology, an MCP host. And at the same time, they've released 2 SDKs as well. So to give you an example of how I use MCP in my day-to-day life, I built uh, a, an MCP server that analyzes the NeoFJ documentation, and then it allows me to verify the claims that we've made with in our courses on Graph Academy. And it is quite a quick thing to build, but the Python SDK allows us to build things really quickly. So we can use the fast MCP class to create a server. So in this case, I'm just creating a server and calling it NeoFJ docs. And then we can use that MCP objects to start to decorate plain functions, which then makes them available to the um, to any host. So I can say, for example, I can create a resource, which is a list. In this case, a list of manuals, but a resource is a fixed piece of information that an LLM may find useful, and then it's up to the LLM to generate to access those tools and resources as it needs them. So it starts off with a decorator at the top, so mcp.resource in this case. The doc string at the start describes what this function does and when it will be useful for an LLM to use it, or an agent to use it. And then some magic happens, and then some content is returned. That's all we need to do to define a resource. So that's for one thing, if you want to read something from the data. If you actually want to perform an action, you can use a tool instead. So we use the tool decorator here. Then we define our function with a set of parameters, and then um, a description of the output. And again, the doc string is important here because it describes to the agent when this tool is useful, and also the inputs and outputs that you can expect from it. And again, some magic happens, and then the value is returned. And this enables that multi-step reasoning, or that React loop. And you can see from this diagram that from the user input going in. So first, the agent decides what it needs to do. It looks at the tools that are available, makes parallel calls to read the content which is in the repository, and then performs some steps to um, access the documentation via resources and tools. So it's reading pages, getting content from there. And then with that context all built up, it then gives it the opportunity to reason on itself, reason on the context that's there. And then you can see on the right hand side, it's produced that result for me. Cool. And so only using the Neo4j MCP server to within Claude, I managed to produce this report. I wasn't brave enough today to do a live demo. LLMs can be temperamental, especially with new models and new things coming up. But yeah, the Neo4j MCP tool provides access to introspect the database schema and then run read and write statements against the database. And in this case, with uh, made a little bit of a back and forth and some correction from a domain expert or that human in the loop. I managed to produce a pretty comprehensive report on the Ian Holloway effect with Swindon Town. So he took over, like I say, with Swindon rock bottom of the league, and then took them to the top. And what this report has done, which is purely a conversation back and forth with Claude, was to describe what's changed and like from a data point of view. But let's go back to that problem of language that Ian Holloway mentioned before. And like depending on who you are and who you're talking to, you may be using completely different terms to describe the same thing. So if the manager, for example, says, we need a 6 with legs who can put it about a bit, this is something that's very specific to that person. So, I mean, in this case, like we can assume that we're talking about a 6 in terms of the number that the player uses. But in this case, we could be talking about a cultured, European 6 central midfielder who likes to drop deep and dictate play 1-2 passes to break the lines and um, progress the ball. Or we could be talking about that old-fashioned English 6, the aggressive centre half who wins their duels and clears their line. So the same term used by two two different people describes two completely different profiles of players with different strengths. But what we need to do is work out that this 6 means in this context a centre back. The term legs means actually we're looking for dual success, interceptions, and puts it about a bit. Maybe someone who puts in a lot of tackles, and we can map those to the metrics that the data providers provide. You can kind of see from here that for these two users who are using the same description of a 6, they're looking for completely different things. And I suppose we can expose that through a tool. So for we can get the profiles for the users and the KPIs and the metrics um, that that apply to that. So we can use the context from from the MCP server to get the user ID and the driver, and then query the database from there. In Neo4j, we do this with a Cypher query. So we're describing a pattern of a user who has a profile with the definition that we've got from the tool call, and then building up information about that. So that the KPIs that it uses, the position that relates to, and that should give the LLM enough context to be able to change what it's searching for and change the queries. And then we can solve this problem of could Busquets win his headers on a cold rainy night in Stoke. And just as an aside, it was so difficult for me to create this just for this niche joke. So I hope you appreciate what's on screen there at the moment. But that's a way of understanding and personalizing what is on the screen. and what a different user sees. Um, and like raw database access can get you surprisingly far. I've been very impressed with what's there. But it makes no sense to use probabilistic prediction engine to continually perform the same task. At best, you're burning tokens and you're spending money and maybe setting a small forest alight. But at worst, you're introducing the inconsistencies. So what you can do is you can take the take the end results. You can analyze the sequence of tools and calls um, made during the reasoning process by the LLM and actually turn it into a tool in its own right. This information fits really well in a graph databases, the kind of flow of memory. And then we can describe our own tools. We can create our own server um, that gives us access to the data, and then performs the magic that we've defined and we've learned from the LLM. So in this case, we're looking at a cipher statement that surfaces the information, which would be the same thing that the LLM would have generated in the past. For domain-specific knowledge, so each of these providers use their own terms. One data provider called StatsBomb uses on-ball value, and then Impact, for example, have data. Everything is around this concept of packing, or how many players you've removed at any point during an action. But what we can do is we can provide a prompt for our MCP server to describe to the LLM what these things mean, and then it's up to the LLM to surface that information at the right time in order to kind of build up that context and avoid that hallucination problem. Now, it's definitely interesting to dig into when to and when not to use MCP. There's a lot of hype there. There's a lot of excitement over MCP at the moment, and it's useful when the data or the functionality needs to be accessed across multiple applications or by many users. And then, like once a provider is written an MCP server, it can be consumed by many users across multiple clients and custom applications without those users and the developers actually having to figure out the underlying APIs and write the functionality themselves. But on the other hand, MCP adds a significant overhead. So the servers need to be deployed and run separately from host applications. The transport mechanisms like standard IO work well for local development. But we found at Neo4j that the production employments require HTTP, HTTPS authentication, rate limiting, monitoring, like all of these things that an application put into production needs. And this adds complexity to the application. So for it's like single integrations and tools that are only required by a single application, writing a function within the application itself makes a lot of sense, and it's much simpler if you're building that application anyway. So I mean, Ian Holloway's advice was just ask ChatGPT, and I can see like with MCP exposing an AI agent to data from a knowledge graph. I think this idea is closer than you think. And then like a tool like Claude Desktop can provide an interface that allows a non-technical user to query structured data with natural language. And then the result will be something that is a human readable insight that can be personalized to that user. And then the user themselves can validate what has been found and also modify what they're looking for using their gut feel and refining that through follow-up questions. So I guess the question is, will this win football matches? I think that still comes down to 22 players on the pitch. But I think that there's definitely an interesting opportunity there to look beyond headline metrics and surface the right information at the right time. So some of the things I would love to dig into would be things like like analyzing data at scale over and doing like deep research to combine different types of data, identify patterns across um, multiple seasons, and then provide personalized player briefings. So you've got a squad of 25 plus players, each, and then maybe a coaching staff of two or three in lower leagues. And I think that generative AI provides the opportunity to surface the right information at the right time to those players, and actually meet them where they are as well. So, for example, using WhatsApp or text messages to send small snippets of information about you, the opposition or the players that they are directly up against for the season. Um, and yeah, and all I can say is really I'm been very surprised and very pleased with the results. And yeah, I mean AI, it's marvelous. Cool. So yeah, thank you all for your time. I appreciate you joining me today and choosing this session. If you want to learn anything, if you want to learn any more about anything that I've talked about today, we have courses on Neo4j Graph Academy on everything that I've spoken about. So we have courses on Neo4j in general. We have courses on generative AI, GraphRag, and then also two courses that have been released in the last month or so around building your own MCP tools. So not only developing applications using MCP tools, but also how to build your own tools that surface information from a graph database. If you have any questions, feel free to reach out. You can find me on LinkedIn. Otherwise, I hope you enjoy the rest of the session.
Thank you so much, Adam. I don't know if you saw these two questions already. I went away, but anybody else have any questions? If not, we can. Oh, oh, yes. Yes, you will have access to the replay shortly after we end the session.
Yeah, I think there's a definitely an interesting question there around cybersecurity, and MCP is a cybersecurity issue. How can you use it to make it safe at the same time? I think this is where I think that the human in the loop is very important, especially if you're doing potentially destructive things. I think when there is a task that could be potentially used in a malicious way, I think it's important to make sure that there's a human who is responsible for approving or rejecting that tool. Like tools like Cursor and Claude Desktop will allow you um, to approve or reject tools as they're run. And that I think is definitely the most important thing. If you're using an MCP server written by somebody else, it's definitely important to verify what the tool is doing and actually understand the underlying code. And yeah, I've always thought of generative AI as a thought partner, not a thought leader. So it shouldn't be. You should be using it to improve your processes, but don't blindly don't blindly follow what it says and let it do what it needs to, or what it intends to. That's great. If anybody has any questions, feel free to reach out to me. I'm happy to answer them.
Thank you again, Adam, and thank you everyone for attending. See you at the next session.